Now let me know once. This should be okay. This must be okay. Once check the quality of video and audio and let me know. Yes, this must be fine. This is a small technical problem. I was not able to go live. So that's the reason for the delay. I think it's all set now. Just confirm the video and audio once. Good morning, everyone. I welcome you all to India's largest e-learning platform, Unacademy. And I welcome you all to the GATE Conqueror channel. I welcome you all to my session of EM Wave Propagation. Subject EMFT. Topic Wave Propagation in different mediums. This is lecture number 4 of this series of EM Wave Propagation. Let's try to confirm the video and audio once. Before we move in, let me introduce myself. I am Chaitanya Reddy, secured AAR 1931. I work as motivational speaker, Pan India for the past 12 years, expert in field theory and communications. This is official Telegram channel of our YouTube channel, Great Conqueror. The GATE Conqueror channel, this is the official Telegram channel. Please make a note. You can interact with us through this Telegram channel. You can interact with all the GATE Conqueror faculty on a personal level through this Telegram channel. Yes, dear. Everyone, try to confirm the video and audio once. Just confirm the video and audio once. We are into EMFT. Completed module 1. Elements of EMF theory. Which is a complete syllabus for triple people and a part of a syllabi for ECE. These elements of EMF theory it studied concepts from electrostatics, magnetostatics, and time varying fields. Electrostatics and magnetostatics were derived as a major concept. We are derived Maxwell equations for static fields. Time varying fields were derived Maxwell equations for time-varying fields. Besides this, I derived some important concepts like, just I am trying to highlight the most important concepts only here, so that those that joined new can understand what is already completed in EMFT. Completed the topics like Poisson's and Laplace equations, and boundary conditions. Also went through the concepts of capacitors and inductors. These were the major topics that we had covered under Module 1, Elements of EMF Theory. The playlist for the same is available on our channel. 40 videos have been uploaded. 50 hours of lecture has been delivered on elements of EMF theory. Good morning, Prakash. I can say for EMF subject, you cannot get more detailed playlist than this. Very elaborated, useful for GATE, engineering services, other competitive exams, all the derivations, all the concepts, applications, previous year questions, practice questions had been covered in this particular playlist. If you have not gone through this playlist yet, make sure that you go through this playlist. If you are from electrical background, EMF will be completely covered here. If you are from EC background, Module 1 will be done. Is that clear? In Module 2 of EMFT is what we are dealing now. EM Wave Propagation. EM Wave Propagation. We are into this module. This will be followed by Module 3. Transmission lines. Module 4. Wave guides. And Module 5. Antennas. In Module 5 antennas, we had already started Antennas Maha Marathon series. 14 videos had been recorded. $30 to $35 hours of recording has been done exclusively on antennas. I'll do a couple of more videos also on antennas, which will comprehensively complete Module 5. This Module 1 is done. This Module 5 is done. We are already into module 2. This is the 4th lecture. We'll finish EM wave propagation very soon and parallelly start transmission lines and waveguides. Is that clear? So in this module 2, EM wave propagation, we had completed EM wave propagation in free space. Free space refers to conductivity sigma is 0, epsilon r is 1 and mu r is 1. Alpha is 0. We got beta is omega into under root of mu naught epsilon naught. Velocity formula omega by beta 1 by under root of mu naught epsilon naught c meter per second. You got this velocity. You got intrinsic impedance as a ratio of magnitude of electric field to the magnitude of magnetic field. You got it as under root of mu naught by epsilon naught, which is 120 pi ohm, approximately 377 ohm. In module 2, wave propagation in free space, we had completed this. And also completed wave propagation in any material sigma is not equal to 0, epsilon r is greater than 1 and mu r is greater than 1. For this, we got attenuation, or we got alpha not equal to 0, beta omega into under root mu epsilon, velocity omega by beta, denominator is greater, therefore it must be less than c. Eta which is E naught by H naught, got it as under root of j omega mu by sigma plus j omega epsilon, and also we derived the generalized expressions for alpha and beta. Alpha we got it as omega into under root of mu epsilon by 2, under root of 1 plus sigma square by omega square epsilon square minus 1, and beta is omega into under root of mu epsilon by 2, under root of 1 plus sigma square by omega square epsilon square plus 1. And And also we have defined loss tangent or dissipation factor tan of phi is sigma by omega epsilon. And if sigma by omega epsilon is greater than 100, it's a good conductor. Sigma by omega epsilon is less than 1 by 100, it's a good dielectric. If sigma by omega epsilon is between 1 by 100 and 100, it's a quasi-conductor or quasi-dielectric. And any given medium, if mod of JC is equal to mod of JD, then loss tangent sigma by omega epsilon is equal to 1. Clear? So this is what we have discussed in our previous classes. Okay, dear. Just let me know any doubts. So this is what we have done in module 2, EM wave propagation in free space, wave propagation in materials, where sigma not equal to 0. With this context, we'll move on. Wave propagation in good conductors. Wave propagation in good conductors. In a good conductor, sigma is far greater than omega epsilon. You know, from generalized expression for alpha, alpha is omega into under root of mu epsilon by 2. Into under root of 1 plus sigma square by omega square epsilon square minus 1. Now you know, for a good conductor, sigma is far greater than omega epsilon. Sigma by omega epsilon is far greater than 1. It is greater than 100. Therefore, in this case, this ratio is a very large value. We can neglect the small values 1 and minus 1. So I can write alpha as omega into under root of mu epsilon by 2 under root of sigma by omega epsilon whole square. Root and square get cancelled. Alpha is omega into under root of mu epsilon by 2 sigma by omega epsilon. Epsilon and epsilon get cancelled. Omega cancels one time. Under root of omega mu sigma by 2. This is alpha for a good conductor. Under root of omega mu sigma by 2. For a good conductor. Is that clear? Yeah. Now if you go for beta, if you go for beta, beta is omega into under root of mu epsilon by 2. Under root of 1 plus sigma square by omega square epsilon square plus 1. Again, this is a good conductor. In a good conductor, sigma is far greater than omega epsilon. This 1 and this plus 1 can be neglected. This 1 and this plus 1 can be neglected because sigma by omega epsilon is a very large value. When they are neglected, the rest of the derivation will be same. Therefore, you must get beta also equal to under root of omega mu sigma by 2, because after that both these derivations are same. These next two steps are same. So you get beta also same. So I can say, conclusion I can say, in a good conductor, alpha is equal to beta. In a good conductor, alpha is equal to beta. Is that clear? Is it clear? So in a good conductor, alpha is equal to beta. If you go for velocity with which the wave is propagating in good conducting medium, velocity is omega by beta. Omega by beta under root of omega mu sigma by 2. Under root of 2 omega by mu sigma. Velocity is under root of 2 omega by mu sigma. And if you see this expressions for alpha and beta, you got alpha is beta for a good conductor, which is equal to under root of omega mu sigma by 2. Am I right? So what is alpha? Alpha is under root of omega mu sigma by 2. For a good conductor, sigma is far greater than omega epsilon, or sigma is a large value. That means what? In good conductor, sigma is large. In a good dielectric, sigma is far less than omega epsilon. Sigma is smaller value. Greater is the sigma, greater will be the loss. It indicates that attenuation is more in a good conductor when compared to good dielectric. Because in good dielectric, sigma is less. As conductivity increases, attenuation increases. Generally, we think that if it is a good conductor, it will attenuate less. But it is not the case. In EM waves will attenuate more in good conductor when compared to good dielectric. Similarly, beta is also equal to under root of omega mu sigma by 2. The wave will undergo more phase shift change, more change in phase shift. If sigma is more or conductivity is more, therefore I can say the change in phase shift is more in good conductor when compared to good dielectric. Coming to the velocity. Velocity is given by under root of 2 omega by mu sigma. In a good conductor, sigma is very large value. Means velocity is less. So good is the conductor, less is the velocity. That means EM waves propagate with less velocity in good conductors. It propagate with more velocity in good dielectric. For suppose you consider an EM wave and you are making the EM wave to pass through a iron rod and a wood log, a iron rod and a wood log, then the EM wave will propagate slower in iron rod when compared to wood log. If you are making an EM wave to pass through an iron rod, it relatively moves slower with less velocity in iron when compared to wood. If you take a wood log, it will travel more faster in wood log. They travel with more speed, more velocity, because velocity with which the wave propagates in a good conductor is less than that of a good dielectric. Very important conclusions. Up to formula, so many people, so many students will know. But if you want to succeed in competitive exams, you must know the logic behind it. You must be able to compare. So these comparisons, these conclusions are very important. In a good conductor, attenuation is more, phase shift change is more, velocity is less. Is it clear? Next, we're done with alpha, beta and velocity. We got alpha C is greater than alpha D, beta C greater than beta D, VC less than VD. And also for a good conductor, alpha is equal to beta. Now, let me define penetration depth. Penetration depth is defined as the distance an EM wave travels into the conductor when it is traveling is called penetration depth, given by delta. It is defined as 1 by alpha. Penetration depth is defined as 1 by alpha. If we consider a good conductor, because we are trying to analyze for a good conductor, penetration depth delta is 1 by alpha is under root of 2 by omega mu sigma. It's under root of 2 by omega mu sigma. Penetration depth delta 1 by alpha is under root of 2 by omega 2 pi of mu sigma. 1 by under root of pi of mu sigma. This indicates that delta is proportional to 1 by under root f. If frequency increases, delta decreases. If frequency decreases, delta increases. That means high frequency waves penetrate less into the conductor. Low frequency waves penetrate more into the conductor. See, this is high frequency, this is low frequency. High frequency waves penetrate less into the conductor. Low frequency waves penetrate more into the conductor. Is it clear? Now, how to understand penetration depth? As I told you, penetration depth will tell you the distance the wave will travel into the conductor when it is traveling through a conductor. That is called penetration depth, and also we understood that high frequency waves penetrate very less into the conductor and low frequency waves penetrate more into the conductor. As high frequency waves penetrate less into the conductor, this small penetration is called as skin depth. Low frequency waves penetrate more into the conductor. This larger penetration is called penetration depth. Penetration depth, remember dear, penetration depth and skin depth are one and the same, but at higher frequencies you call it as skin depth, and at lower frequencies you call it as penetration depth. Now, to understand more about the skin depth or penetration depth, let me analyze wave propagating in a conducting medium. For a wave propagating in a conducting medium, E is equal to E naught into e power minus alpha z into e power j of omega t minus beta z ax. This is a wave propagating in a conducting medium, as we had seen in topic number 2. Omega t is change of phase with respect to time, beta z change of phase with respect to space. Clear? Is it clear? So omega t will give you the change of phase with respect to time. Beta z will give you change of phase with respect to space. Omega t minus beta z indicates that the wave is propagating the positive z direction, and this gives you amplitude variation. This gives you phase variation. Because we are calculating the penetration depth, I consider the amplitude variation at z is equal to 0. That means on the surface of the conductor, E is equal to E naught into e power minus z into 0. This is E is equal to E naught. Yes, true. Z is 0 means initial amplitude. Initial amplitude is E0, correct. E is equal to E0, initial amplitude, correct. When Z is equal to, it has traveled a distance of delta, which is called penetration depth. When it has traveled a distance of penetration depth, what happens? E is equal to E0 into e power minus alpha. Z is delta. It has traveled a distance of delta, penetration depth. But you know that delta penetration depth is equal to 1 by alpha. Substituting E is equal to E0 into e power minus alpha by alpha. After it has traveled a distance of delta, E is equal to E0 into e power minus 1. E is 1 by E of E0. E is 1 by E of E0. E is 2.718. 1 by E is 0.368. Therefore, we get E is equal to 0.368 of E0, indicating that the penetration depth is the distance travelled by the wave such that its initial amplitude is decreased to 36.8%. I repeat it again. Penetration depth is the distance travelled by the wave such that its amplitude is decreased to 36.8% of its initial value. Such phenomena is called as penetration depth. Is it clear? Everyone, is it clear? No. That's about the penetration depth. We'll go for intrinsic impedance. Given by eta. Next is intrinsic impedance given by eta. For any general medium, sigma is not equal to 0. Intrinsic impedance eta is under root of j omega mu by sigma plus j omega epsilon. Because this is a good conductor, sigma is far greater than omega epsilon. Therefore, neglecting the second term here, eta under root of j omega mu by sigma. Eta in a conductor is called as surface impedance. And surface impedance can be written as Rs plus Jxs. Clear? In a good conductor, intrinsic impedance is also called as surface impedance, and this surface impedance can be written as Rs plus Jxs. Rs is surface resistance and Xs is surface reactance, under root of j omega mu sigma by 2. Under root of j omega mu by sigma. Now, LHS is in the form of x plus jy. Try to write RHS also in x plus jy. Tell me how to convert root j equivalent. Root j equivalent. Root j can be written as 1 plus j by root 2. How to write this? Root j is under root of 2j by 2, which is under root of 1 plus 2j minus 1 by 2. Root j is under root of 1 plus j whole square by 2. Root j is 1 plus j by root 2. Therefore, I can write the shortcut for root j is 1 plus j by root 2. Eta, which is rs plus jxs, root j is 1 plus j by root 2. 1 plus j into under root of omega mu by 2 sigma. From this, surface resistance rs given by under root of omega mu by 2 sigma, which is also equivalent to surface reactance. Surface resistance given in ohms, under root of omega mu by 2 sigma, and you can write this in terms of delta as multiplying and dividing by sigma under root of omega mu by 2 sigma. This is 1 by sigma of under root of, this will come in omega square, omega mu sigma square and 1 sigma get cancelled. Rs is 1 by sigma of under root of omega mu sigma by 2. What is under root of omega mu sigma by 2, which is alpha or beta, which is equal to 1 by delta. If you want to write Rs in terms of delta, then it is 1 by sigma into 1 by delta. 1 by sigma delta. This is expression for Rs in terms of delta, very important. Now, eta is 1 plus j times of under root of omega mu by 2 sigma. If you are writing in R angle theta form, eta is 1 plus j times of omega mu by 2 sigma. Writing in R angle theta form, eta is, R is under root of x square plus y square, under root of omega mu by 2 sigma plus omega mu by 2 sigma, it is under root of omega mu by sigma, that is R, angle tan inverse of y by x, 145 degrees. This is in polar form. This is mod of eta under root of omega mu by sigma, and this is theta n, 45 degrees. This theta n is related to tan phi, lost tangent, where phi is 2 times of theta n. Is it clear? So that's about wave propagation in good conductors. In a good conductor, alpha is equal to beta, velocity omega by beta, under root of 2 omega by mu sigma. In a good conductor undergoes more attenuation, more change in phase shift. Wave propagate with less velocity. Penetration depth is a depth into which the wave penetrates when it is traveling. It penetrates less at higher frequencies and penetrates more at lower frequencies. The lower penetration at the penetration at the lower frequencies are the penetration that happens at low frequencies is called as penetration depth, and the penetration that happens at higher frequencies is called as skin depth. From that, I can define that the penetration depth is the distance traveled by the wave into the medium when it is traveling in a given conductor, or I can say that penetration depth is the distance traveled such that the amplitude, the initial amplitude is decreased to 36.8%. So for example, you know that penetration depth is 0.1 meter. That means what? When the wave is propagating up to 0.1 meter, its initial amplitude will be decreased to 36.8%. For example, initial amplitude is 10 volt and the penetration depth is 0.1 meter. That means it is giving you an understanding that when the wave will penetrate at a distance of 0.1 meter, its amplitude is going to be 3.68 volts. Is that clear? Given a problem that delta is 0.1 meter, initial amplitude is 10 volt. What it is telling you is, after that the wave is penetrating by 0.1 meter, the amplitude initially at the surface was 10 volt. At 0.1 meter it will become 36.8%. That is 3.68 volt at this point. How do you got this? By concept of penetration depth. Because given that penetration depth is 0.1 meter. Is it clear? Everyone, let me know. Okay. Fine. So this is wave propagation in good conducting medium. Wave propagation in good dielectrics. We know in a good dielectric, sigma is far less than omega epsilon. We know from general expression for alpha and beta, alpha is omega into under root of mu epsilon by 2 into under root of 1 plus sigma square by omega square epsilon square minus 1. Now, we know that in good dielectric, sigma is far less than omega epsilon. Sigma by omega epsilon is far less than 1. So, in this case, you cannot neglect this 1 and minus 1. Because this is a very small value. That's the reason why we need to evaluate this inner root, under root, by using binomial expansion. Under root of 1 plus sigma square by omega square epsilon square is nothing but 1 plus sigma square by omega square epsilon square whole power 1 by 2. These are the form 1 plus x whole power n is 1 plus nx, n into n minus 1 by 2 factorial x square, and so on of the binomial expansion. If you apply the binomial expansion here, 1 plus x whole power n, 1 plus nx, 1 by 2 to sigma square by omega square epsilon square plus n into n minus 1 by 2 factorial. Here n is 1 by 2. Okay. N into n minus 1 by 2 factorial into x square. Already sigma is far less than omega epsilon. Sigma by omega epsilon is far less than 1 already. And here you have sigma by omega epsilon whole square, which will be far less than 1. And if you want x square now, it will become sigma by omega epsilon whole to the power of 4 will be very less. Therefore, neglecting higher order terms, only will take up to 1 plus nx. So, under root of 1 plus sigma square by omega square epsilon square can be written as 1 plus sigma square by 2 omega square epsilon square. Therefore, alpha is equal to omega into under root of mu epsilon by 2. Now, under root of 1 plus sigma square by omega square epsilon square can be written as 1 plus sigma square by 2 omega square epsilon square. Alpha value minus 1. This get cancelled. Alpha is equal to omega into under root of mu epsilon by 2 into sigma square by 2 omega square epsilon square. This omega, once it will come in, it cancels out with this omega square. Sigma square will move out, it will become sigma. 2 into 2, 4 will move out, it will become 2 into under root of mu, 1 epsilon will get cancelled. Alpha attenuation in a good dielectric is sigma by 2 into under root of mu by epsilon. This is the formula you need to use to calculate alpha for a good dielectric. Clear? Yes, dear. Is it clear, everyone? Okay. Now, beta. Alpha is done. We'll go for beta. The generalized expression for beta, omega into under root of mu epsilon by 2. Under root of 1 plus sigma square by omega square epsilon square plus 1 is a good dielectric. Therefore, sigma is far less than omega epsilon. Sigma by omega epsilon is a very small value. We cannot neglect 1 plus 1. 1 and the other 1 we cannot neglect. Therefore, applying binomial again, under root of 1 plus sigma square by omega square epsilon square is 1 plus nx, 1 plus sigma square by 2 omega square epsilon square. I am avoiding to expand this again because it is same as this. With the same logic, same neglecting higher order terms, everything same. So I am writing this answer directly. 1 plus sigma square by 2 omega square epsilon square. Then substitute there. What do you get? Beta is equal to omega into under root of mu epsilon by 2. 1 plus sigma square by 2 omega square epsilon square plus 1. Okay. Solving this, beta is equal to omega into under root of mu epsilon by 2 into 2 plus sigma square by 2 omega square epsilon square. Taking 2 common and cancelling it out, beta is omega into under root of mu epsilon to 1 plus sigma square by 4 omega square epsilon square. Applying the binomial again, neglecting the higher order terms, beta is omega into under root of mu epsilon into under root of 1 plus sigma square by 4 omega square epsilon square. Applying the binomial again and neglecting the higher order terms, what is there inside here? Under root of 1 plus sigma square by 4 omega square epsilon square, which is 1 plus sigma square by 4 omega square epsilon square whole power 1 by 2. Writing it as 1 plus nx 1 plus sigma square by 8 omega square epsilon square, and neglecting the higher order terms with the same reason that sigma is far less than omega epsilon. Therefore, this is beta is equal to omega into under root of mu epsilon into 1 plus sigma square by 8 omega square epsilon square. This is the expression for beta for a good dielectric. Alpha is done, beta is done. Now we'll go for velocity. Is omega by beta. But omega by beta is omega into under root of mu epsilon 1 plus sigma square by 8 omega square epsilon square. Velocity is 1 by under root mu epsilon 1 plus sigma square by 8 omega square epsilon square whole power minus 1. This is of the form 1 plus x whole power minus 1, 1 minus x plus x square minus x cube plus x to the power of 4 minus so on. This is the expansion. Again, as sigma is far less than omega epsilon, higher order terms can be neglected. Here I can write it as 1 minus x. After that, all the higher order terms can be neglected. Velocity is equal to 1 by under root of mu epsilon to 1 minus sigma square by 8 omega square epsilon square. Is it clear? This is for a good dielectric. Intrinsic impedance eta under root of j omega mu by sigma plus j omega epsilon. Now, sigma is far greater than omega, far less than omega epsilon in a good dielectric. Therefore, eta is under root of j omega mu. J omega epsilon you take common 1 plus sigma by j omega epsilon. Eta is under root of mu by epsilon. This will move up whole power minus 1 into whole power 1 by 2. Whole power minus 1 by 2. This is 1 plus sigma by j omega epsilon to whole power minus 1 by 2. Do it binomial. Eta is under root of mu by epsilon into 1 minus sigma by 2 times j omega epsilon. You know j square is minus 1. J into j is minus 1. J is minus 1 by j. So minus 1 by j can be replaced by plus j. Eta is under root of mu by epsilon. 1 plus minus 1 by j is plus j. J times sigma by 2 omega epsilon. This is for a good dielectric medium. These values are for good dielectric. Good dielectric. These are values for good dielectric. If you go for perfect dielectric, in perfect dielectric, sigma is 0. Therefore, alpha is 0. In perfect dielectric, sigma is 0. Beta is omega into under root of mu epsilon. In perfect dielectric, sigma is 0, therefore velocity is 1 by under root of mu epsilon. And eta is under root of mu by epsilon for a perfect dielectric. With this, analysis of wave propagation in different medium is completed. Any doubts here? Clear? So if you try to analyze what we have done so far, wave propagation in different medium, let me start with free space. In free space, conductivity is 0. Thereby attenuation is 0. Beta is omega into under root of mu naught epsilon naught. Velocity is 1 by under root of mu naught epsilon naught, which is c. Eta is under root of mu naught by epsilon naught, which is 120 pi or 377 ohm. These are the values for free space. If you consider perfect dielectric, because perfect dielectric and free space are very close to each other. If you consider a perfect dielectric, there also sigma conductivity is 0. Attenuation constant alpha is 0. Beta is omega into under root of mu epsilon. Velocity is 1 by under root mu epsilon, which is c by under root of mu r epsilon r. So very clearly velocity is less. Velocity is less than c because mu r and epsilon r are greater than 1. Eta under root of mu by epsilon 120 pi into under root of mu r by epsilon r. Always mu r is less than epsilon r. And epsilon r is greater than 1. Therefore, eta will be less than eta naught. Free space, let it be eta naught. Next. For a good conductor, sigma is a very large value. Alpha is under root of omega mu sigma by 2. Attenuation is large. Beta is also large. Velocity is less. V is under root of 2 omega by mu sigma. And eta is under root of omega mu by 2 sigma plus j times of under root of omega mu by 2 sigma. That's for good conductor. It's for a good dielectric. For a good dielectric, sigma is a very small value. Alpha is sigma by 2 into under root of mu by epsilon. It's also small value. Beta is omega into under root of mu epsilon. 1 plus sigma square by 8 omega square epsilon square. I'm trying to hide the video here because I want to write there, okay? Velocity under root of 2 omega by mu sigma. That's for good conductor, I'm right. Good dielectric, I was speaking. Yeah. Good dielectric velocity one by under root of mu epsilon 1 minus sigma square by 8 omega square epsilon square. Eta under root of mu by epsilon 1 plus j times of sigma by 2 omega epsilon. And for a perfect conductor, sigma is infinity, alpha is infinity, beta is infinity, V is 0 and eta is 0. Now if you try to analyze this, listen carefully. If you try to analyze this in free space, there is no conductivity, 0. In perfect dielectric also no conductivity, 0. In a good conductor, conductivity slowly it increases. In a good dielectric, if you go for free space, 0. Perfect dielectric, 0. Good dielectrics, small conductivity. Good conductor, little more conductivity. Perfect conductor, very high conductivity. Attenuation. For free space, attenuation is 0. For perfect dielectric, also it is 0 because sigma is 0. For a good dielectric, small amount of attenuation will be there because sigma is small. For good conductor, attenuation increases. For perfect conductor, it becomes infinite. Next, if you go for beta, this is the least value that is possible for free space. For perfect dielectric, it increases because mu r is greater than 1, epsilon r is greater than 1. For a good dielectric, it still increases. For a good conductor, it still increases. For perfect conductor, it becomes infinite, max. Velocity is equal to velocity of light in free space. It decreases in perfect dielectric. Further decreases, you can see minus here. Further decreases in good dielectric because it has small sigma value, it decreases. It decreases with a huge value because sigma is very high. In good conductor, it becomes 0 in perfect conductor. From C to 0, continuously decreasing. Eta is 377 ohm for free space and it is less than that for a perfect dielectric. And in both the cases, eta is a real value. Whenever there is conductivity, eta will become complex value. Wherever there is conductivity, eta will become complex value because reactance component will come into picture. Is that clear? This comparison is very, very important here. This completes wave propagation in different medium. In the next class, we will do numerics related to wave propagation in different medium. Unacademy provides you 2 paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly tests, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, you have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study material, specialized notes and practice sets, personalized test analysis. This will be useful in understanding your weakness. And study booster sessions or workshops and customized study planner. All this in Iconic. Iconic includes all the features of Plus also. If you are considering a Plus subscription or an Iconic subscription, go for a no-cost EMI where total cost will be divided by number of months. This is very much suitable for students because we are not charging anything extra here. The same cost we are dividing by total number of months, which is very much useful for you because you are not paying anything extra here. which is student friendly, and moreover, if you use my code GCR10, you'll get an extra 10% off. And if you're going for iconic subscription, you get a personal coach for you or a 1:1 mentoring, increasing of your chances of getting a top rank. And if you take a subscription today or tomorrow, then as Republic Day special, with every 12-month subscription, we give away 6-month subscription extra for you with the same amount. And also you can use my code GCR10 to avail extra 10% off. It's almost like 43% off if you calculate. It's a huge discount here. It's a very, very huge discount. Try to utilize or capitalize this. And if you want to check your caliber, prove your caliber, you can go for the Combat. Combat is a live quiz competition where 20 questions will be asked, 60 minutes will be given. It is on January 30, this Sunday, 11 a.m. Separate paper will be given for mechanical, civil, electrical, ECE and CSID. The toppers will get so many discounts here, and the students who top this will stand a chance to get a free subscription, and we are ready to give away scholarship worth of 4 crores. And the good thing is 100 lucky participants, irrespective of your performance, you stand a chance to win all these gifts also. But Unacademy is conducting All India mock test in the complete January. This is also for free. You can use my code GCR10 to enroll yourself. This is the best platform for you to verify your preparation level for GATE 2022. Even 2023 aspirants can also have a go of this All India mock test so that they understand where they are starting for GATE 2023. These are the special class features here. We have interactive live classes for the learners, polls for the learners, raise hand option. You never miss a class when the notification is on. And you can download the lecture notes anywhere. Once the class is done, you can access anywhere and any time. This is a new feature here, Unacademy Ask a Doubt, through which you can ask unlimited number of doubts and get them clarified in your preferred language. It is very, very simple for you to post your doubt. So dear, we are here to clear your doubts, and these are the new batches where GATE 2024 for ECE will start on 27th of January, tomorrow. Ascent GATE 2024 electrical will start tomorrow. Ascent GATE 2024 for ECE will start tomorrow. Spare GATE 2023 for electrical. Spare GATE 2023 for ECE. Evolve GATE 2023 for ECE. Evolve GATE 2023 for electrical. And these are the other batches for all the other branches. For all the branches, new batches. All of them starting from tomorrow. For all these batches, you can use my code GCR10 to avail extra 10% off. And remember dear, today and tomorrow, you will get 6 months extra subscription also on 1 year subscription. You will get 18 months subscription at the rate of 1 year, and you get an extra 10% off if you are using my code GCR10. Thank you one and all for joining the session. A big thank you from Unacademy. A big thank you from GATE Conqueror channel. A big thank you from myself. Thank you all dear. Have a good day.